Thank you. So you give the microphone to an Italian with 40 minutes delay and you hope we are on time, huh? Okay, that's the first challenge we start with. I'm Sardinian, so I'm gonna take care of this, don't worry. So I'm very honored, actually, humbly honored to be here. It's quite a thrill. Absolutely important. The set the stage was already done by Pierre and of course Wolfgang, and everything was said and done before me. I'll go as quick as I can, but I want to put some things settled, although if I sound assertive, I'm not at all. I'm full of doubts, and in preparing this talk, I had to almost constantly change it. I refused to change it this morning when I saw that the payers in the US yesterday night approve and reimburse the first app for insomnia, which of course is going to be huge as the impact. But this is what is happening in our field, in the digital brain. I have also to disclose the fact that being the Director General of the Italian agency, which is also a payer for 5 years, and IMA, CHMP, and scientific advice, all the things that I will put forward here are my personal opinion. They've never been discussed nor endorsed by the official regulators. And since I'm a psychiatrist, I like to start with a test for you. What do you see? See, you heard the two things, a rabbit or a duck, right? You see, right? A rabbit or a duck. Let me change a little bit the perspective. What do you see? Yeah, a rabbit becomes dominant when you move the thing. So assuming that the face of the rabbit, the face of the rabbit is there, if I do this, what do you see now? A duck. Of course, you're right. I mean, both things, depending what this is, it can be a rabbit or a duck. The metaphor is used by Thomas Kuhn in this small book, in which he studies the way scientific revolution really happens. So what it means is that given a certain amount of data and representation of a scientific construct, okay, let's say it's the duck, okay, and let's think about this as brain health. So the duck is our brain health. For ages, for decades, we thought this was the right representation of what the brain health was. But in the revolution we are, this is most likely is not a duck and is a rabbit. And as a rabbit, is running very fast, okay? And that's what the revolution we are on actually is. This is a bold statement, 2011, made by Craig Venter in Nature, Science, a small editorial, in which he put this forward in this very clear manner. He says, look, biology and medicine as we know them, they are dead. They have become information science. And information science then brought about the 4P of personalized medicine, of which I have taken the liberty to highlight the really most important one. The most neglected one in the beginning, you probably remember. Nobody was really care about this. Everybody was jumping to predictive, preventative, and personalized. And why? Because everybody in pharma, in stakeholders, in healthcare providers, in patient, even in patient representative, were thinking about medicine as the duck. So the duck needed to be like this. Oh, so we're going to go digital for what we were doing analogical. No. This is a completely different thing. It's a completely different animal, indeed. And participatory is at the center of this. I forgot, the slides are for you. So you just text me on Twitter, I'll send you the slides. So these are my statement on principle. what was going to happen is that the intensification of digital product in these 4 main areas, but I might think even more, biomarkers, tool for population stratification, which will have big implication for drug discovery, for instance, outcome assessment, which is going to be completely changing, siteless trials, many way of following in real life the life of individuals, and medicinal products, and the digital medicinal products. I touched upon this at the end of my talk. The reason why digital in the brain is so significant is that our biological knowledge, as was saying by Pierre, of what really brain does is still very limited, and the way it works. So we can have what is called a digital phenotype, or what are the behaviors. And this will allow a rather precise characterization of the behavioral variability. And that is the important issue. It's not the characterization per se. Again, do not think about the duck. We are changing the reference frame. This is what is happening. So let's start with the facts. This is the fact. The amount of population is steadily increasing, constantly increasing in the world, very recently, in exponential manner. And we have mental issues that, depending on the area, will range from about 2 individuals out of 10 to about 4 individuals out of 10. So all the diseases that are related to aging will escalate. Aging of the brain will, of course, escalate. What do these people do? What do they use? They use an incredible amount of connected devices all the time, continuously. If you have a phone, they can take pictures, which I see you do. And as a GPS, you basically are in the grid. You are in the grid, and you are carrying one of your personal computational device on you all the time. And it's constantly giving you information, and you're always giving information on the net. This is Pope Ratzinger inauguration, 2005. And this is Francesco, the first inauguration, 8 years later. I can take zillions of pictures like this, and you will see this becoming absolutely exponential. What you have today is this amount of data. The amount of data that is generated is unprecedented. By next year, every one of the person that are connected or not connected in the world will generate 1.7 megabytes per second from 200 billion connected devices, meaning connected cars, connected refrigerators, connected scales, connected not only phones. This will be a continuous stream of data generating an amount of information. I will be very careful to say not knowledge, so information at best, that will populate the entire space. We will have 40 zettabytes of health data by next year. This is a slide that I always present because it's quite shocking for people in the audience to think about these things in terms of numbers. You see, the human brain is unable to represent zettabyte, 10 to the 21st. It does not have the capacity to give a significance to this number. You have 4 V's, the important 4 V's of big data you have heard about. There are other V's, but these are the fundamental one. One is volume, so basically the scale of the data, the amount of the data. The other one is velocity, so how fast these data stream in the cloud, from the cloud, and they get analyzed. The variety, how these data are different from each other, and then veracity, how they are certain. Now, which of these V's is most important to you? Veracity. I should publish a paper on this. Every time you ask this question to a scientific audience, the response is veracity. Who of you is an IT coding guru here? Okay, one. She would probably say, wait a second. What I would like really to know more is variety. Variety, for me, is very important. Because the amount of data is so big that in a second I will show you that all the other V's are not important. And how big is a zettabyte? Since we have 40 zettabytes next year. Now I'll show you how your brain can represent. If 1 byte equals a grain of rice, which now you can represent in your hand, then 1 zettabyte will fill the Pacific Ocean with rice. You could walk. It would take you a while, but you could walk. So now we're going to have 40 of this by next year on health data, which does not mean that we have 0 now. We are over 30 zettabytes at this moment, okay? Since the numbers are like this is why the other variables are less important. This is the sampling of normal distribution. Assuming there is normal distribution, which I don't think normal distribution is the case in health disease, but let's, for the sake of the argument, let's say it is, then see what happens when you change from 5 observations to 10,000 observations. But 10,000 observations for the volume of data we are discussing are nothing. Every year, the machines that are connected to the lab, they take blood tests. So the big machines, the Roche machine, the Siemens, the LabCorp, all those, all the machines that regulate this data, they put out over in excess of 50 billion data points. So if you ask this machine, what is the cholesterol level on Brussels, they will tell you exactly what is the mean. If the number is big enough, then the mean of the number approximate to the exact, the real value of the normal cholesterol. Don't tell this to WHO, huh? Because this will kind of change all the guidelines and all the things and all blah, blah, blah. Yeah, you said I have to be provocative. I'm provocative. You called me, you got me, This is another implication. This comes from IBM Watson. When was asked to the people that were analyzing this data, where you want to take your source of data, well, you say, well, we can take it from the clinical factors that I just mentioned about. So all the entirety of all your blood tests and NMR and whatever you name it, and clinical visits and all the doctor notes and everything, this will, in your lifetime, will basically fill up the disk of your personal computer, 0.5 terabyte. And it will represent 10% of the total information. Another 30%, as you know, can come from your genomic factors, but only as structure, so as sequence. And this will be about 6 terabytes. Over 1,000 terabytes of information will come from what you do with your regular daily life. So if I can follow you, then I'll know what are you doing. And I can represent many organs and therapeutic areas, for instance, cardiovascular probably, depending on the famous 10,000 steps on your cardiac output and things like this. But for sure, I can approximate the way your brain works, because that's your behavior. And that's what the brain does, controls behavior. So this is what are going to be the clinical implication of big data. You will hear, as you've heard already from the opening remarks, a new organizational model. You will have changes in this major area. A very, very interesting new individual will come up. And I totally agree with Pierre. When we arrive to the patient level, it's way too late. And there's going to be no system that can sustain at the patient level, not even at the early patient level. So the new individuals that we need to intercept is this one. It's a healthy individual at risk. Think about it for 1 second. It's a little strange, no? It's healthy. Technically, it's healthy. So there are no signs of anything happening. But is it a risk because the behavior of it, combined with his genetic background and many other things that we can actually summarize, are making him or her at risk in the near future? We need to interject there. And for mental disorder, for brain disorder, this is absolutely paramount, assuming that we can change the progression of the disorder somehow. Okay, so how do you then elaborate and use things from this device? You use this kind of stuff, basically. Use iterative approach, use massive amount of artificial intelligence, machine learning, and then you try to integrate structured and unstructured data that I will touch upon a little bit, because this is really the vault of what things happen. There are pitfalls, of course. There are going to be a lot of junk in, junk out. The trash comes in. It's very, life is dirty, if you haven't noticed yet. It is dirty. It makes dirty things. It's very difficult to move from beautiful designed, specific, I'm looking at Daval, clinical trials, all neat, in inclusion, exclusion criteria, everything is cool, to what happens in real life. So you have a lot of missing value, you have unrealistic value, you have very difficulties in preparing the further elaboration, so it's something quite remarkable to do. What are we using now? We're using basically sensor for activity. This is done. This, 3 years ago, it was coming. This is completely done. People are using sensor for, don't think only about walking, many things, sleep pattern, food, all kinds of behaviors. Pattern recognition, and I will show you a brief example of pattern recognition, and then the most sophisticated frontier is the human-to-machine interface. So what do you do, the way you handle your phone, for instance? Not only what you're typing, but the way you're typing, at what time, what speed, combined with speech recognition, those are the levels of the human-machine interface where things are happening. Pattern recognition, this paper just came out. A convoluted neural network beat constantly dermatologists in recognizing the difference between a nevus and a potential deadly melanoma. Now, if I want to be very bad as a referee, the only thing I would say, which is flaws in this paper, is these dermatologists were quite young, about 55%, 60% of them had less than 5 years of dermatological experience. So their brain archives, their personal brain archive was very small. However, the convoluted neural network had no previous knowledge of anything, was not even young, was zero, was an infant. It kept learning and learning and learning and learning. Now, the database for melanoma and nevi, confirmed by biopsy. So every time you tell the machine, this was really a melanoma. Now the machine matches. It's in over 300 million images. So these networks are becoming very, very powerful. If you think about going to dermatology as your specialty, talk to me, because, I don't know, it can be, and not that psychiatrists are in a good situation. This is the ability of psychiatrists to rule out psychosis. They are very good. They are quite remarkable. So this is a young individual, the healthy person at risk, who is having the first sort of psychotic break. He comes to a psychiatrist. The vast majority of the cases, 90% of the cases, are able to say, and rightly so, you're not going to have a psychotic life. They are very good. What they are not good is to say, you're going to have a psychotic life. This is our human nature, you see. We hope that you're not going to have a psychotic life. We are psychiatrists, we see many like you, but perhaps this time I doubt myself. Perhaps this kid is not going to be psychotic for the rest of his life. You know, he's 16, 14. You know what's ahead. Machines have 100% ability to spot in and spot out. They never fail. What they do pattern analysis of your speech. They interpolate how long your sentences are going, how you brag about your sentences, and how deteriorated the grammar is. You start talking and then you flows. If for the psychiatrists in the audience, you know what I'm talking about. The language is destructured. And the longer you talk, the more destructured becomes. The machines is very keen in spotting up these two very easy algorithms. It says, he's going to go into it, or she's going to go into it. Never fails. So also psychiatrists might have a bad future, not only dermatologists. These are the opportunities of the digital biomarkers. Of course, the memory, executive function, these are passive. You can do it automatically. Movement, where you go, are you doing it? You can, of course, measure cognitive domain in the middle of the day. I can submit you a task, see how you're doing, if you are deteriorating or not. And by the way, another thing that is interesting about these measurements and these phones is you carry them with you. So you are your own control all the time. If you are deteriorating, you are deteriorating, not somebody else. Of course, there are some issues that you need to address. Most importantly, this is something that Tom Insel with his MindStrong work discovered, is that depressed patients fail to charge the phone. So the data is completely missing, but you don't, if you are a statistician, how do you do about this? It's missing at random, you cannot do last observation carry forward. The regulator will not like this. They will not like base observation carry forward either. So what do you do? The lack of charging a phone should be considered as a symptom, and what kind of symptoms? So these are the issues we need also to discuss. My regulatory mind, of course, cannot, although give you some recommendation on this. What are the issues about all these digital markers, tools that we are using? Well, they have to be reliable. They have to have validity and practicality. As you said, this data has to be as truth as possible to represent reality. Otherwise, I will not be able to elaborate the numbers. Is the device measuring what you think is measuring? Is the device as a representation with the animal models that we know? It's not that you throw away all the biology that we have studied, right? So does the device and the measurements of the device represent the knowledge that we had so far? How do we bridge this? So the regulators most likely, and I give you some example, will ask you to work on the using of the device to enrich the population in the beginning. So stratification of the population by using the device can be something useful. Regulators will most likely advise you against using endpoints primary from digital per se. We are not there yet. They will ask you to link them as surrogate, as a secondary. Raji will comment on this, but this is the feeling without denying the importance of this, the feeling that we have now in this field. Finally, can you replace phase 4 studies with all these digital things? Probably yes. Probably you could do this. They can be used to improve the social activity in people with depression. You could eventually identify the healthy person at risk. And the healthy person at risk is a combination between the spectrum of the disorder and the prodromal of the disorder. And let me give you a little hint of this. The spectrum to the prodromal, it's a cultural concept. We need to agree on this. We need to agree on the fact that disorder in the human brain do not represent themselves like this, in a categorical, divided type of thing. There's a threshold, there is not a threshold. If you have this, you are psychotic, this, you are not psychotic. You have this, you are Parkinson, this, you're not Parkinson. It's rather a continuum of things that are in the spectrum of this disorder, in the subthreshold, not subthreshold, is where the prodromal start converting. And you need to act as early as possible to avoid that when the prodromal becomes something of clinical relevance, then the time of the treatment has already gone, as Pierre was saying. So the spectrum disorder are very, very challenging. Think, for those of you who are in pharma or are interested in the therapeutic indication, think how do you label a therapeutic indication in spectrum disorder? What is the population? The bigger the spectrum, the more difficult the numbers. Statistician will jump in, will say, oh, no, yeah, sure, you can do this. I need N equals 10,000 per arm, at least, to see if this is as a label. So the biomarkers can be found and probably used to enrich the patients. And it's a continuum versus spectrum, and IMA has given some indication, FDA has given some indication. This can be applied to schizophrenia, to Alzheimer, to Parkinson's disorder, multiple sclerosis, you name them, okay. So this digital shift that goes toward the treatment of an early prodromal state is based on the assumption that the brain produces behavior in the environment. And this brain-produced behavior can be followed by the so-called ecological measurements. Once the ecological measurements are agreed upon, and I would advise to ask for scientific guidance from the regulators on this, if you are developing a medicine. If you want to develop a medicine or a diagnostic tool, it won't hurt to go in front of the FDA, go in front of IMA and says, look, we would like to do this. What do you think about what kind of qualification do you need for us? This field is full of absolutely genius kids. They are kids, really, 19, 20. They code and design and they make up every other day, which are able to measure everything. But sometimes they forget things like certification, reproducibility, backlogs, duplication, mirroring, basic things that, the easiest regulatory guidelines will tell you. They just forgot. And so sometimes some of these measurements cannot be used, even if they are there. There are 380,000, I'm not kidding, apps for health in the Android Google Store App Store. Almost 400,000. Vast majority are fitness and things like this, okay? But of this, only five meet the criteria for something that can be used in the regulatory setting. Payers are less strict. Because if I have your phone is showing that you're going to work from 9 to 5 and you are walking around, I can start considering removing the caregiver. But for regulators are much tougher, and of course they should be. No. You have seen this, the digital phenotyping in autism, for instance, quite interesting. But this is just to point out that some of the sensor technology and some of the technology I was talking about are at the very advanced stage of progression in biomarker. Others are within the same disorder, using the same type of technological complexity. Some are less prone to arrive to the market. Some are ripe, and they can provide a lot of information. And a lot of came from the IMI, actually, a huge type of program. The conception is one, the UAIMS is another one. Many of these achievements have been done under the umbrella of the IMI projects. Another thing that is happening that you should know about, and I go for closing, it's on digital therapeutics. So now you could actually treat disorder using digital. No use of any drug of any kind. And this digital therapeutics can be used independently or with the medications. They have been validated by regulatory body. They've been reimbursed, and they are reimbursed by payers, mostly in the US, but they are moving all over the world. An example, the first example was probably this one, you know. This is a technology, it's called Proteus. This is combined to the regular medicine, in this case was aripiprazole, and this is an in silico small battery. There is a transducer. The moment this little sensor touches the chlorhydric acid of the stomach, the layers of silico gets activated and send a signal to the individuals. So now we know that this pill has been taken. This is aripiprazole, so it's an antipsychotic, something for which adherence, you know, is quite remarkable to have. And then it gives a lot of other parameters. There are other 30 products in development for this, so you will see more and more coming. What are the caveats? First of all, what is the assessment, the quality assessment of the medical device? That's quite a challenge for the regulators, because we don't have assessors that are expert in radio transmission. We are pharmacists, medical doctors, and you know, PhD in biology or biotechnology, not in radio transmission. But these are the challenges that will come with digital medicine. Digital medicine will use other codes, other type of language. How do you interpret the data on the significance? How do you compare with other devices? What is the standard of care in other devices? There is none. So that is an issue. This is another software. This is Peer Therapeutics. Peer Therapeutics is an interesting company. They were developing an app, a software app, that will help people with substance abuse disorder to stay in retention in the therapy without relapse. Classical app, they could sell it over, you know, the Apple Store or the Google Store. They choose instead, and boldly so, very bravely, to go in front of the FDA and says, please, regulate us. So regulate our software. And FDA asked the classical question they would ask in terms of a medical product, and they came out with a very good score, and so they got approved and reimbursed. Another project, which is, you probably have heard, is the Evo project from Achille. This is a game instead, not a software to retain abstinence. This is a game for kids. The kid, individuals with ADHD will play this game, and by playing this game, the endpoints, the classical endpoints, you know, in the attention deficit disorder, would you stand still, sit, would you concentrate, things like this, were met with a P of 0.006, you see it there, in phase 2. What was the control arm? Was a scramble game. So the same type of principle, but not, allegedly, this is what the company says, not rewiring the part of the brain was needed to keep the attention. So these are the things we are discussing. And these are the regulatory challenges in this. Of course, video games, for one, are assessed like medicine safety. They don't have the safety concern of medicines. They are not medicines. What other safety concern do they have? Do we know it? And don't tell me, oh, too much video game is bad, because that is not enough for the regulator. And by the way, if this shows that the more they play, the more perform in school, then, you know, where is the threshold line here? So these are so I see the time is running. Let me go on these few points. This is another issue that I want to come up with. Pierre has asked for some ideas coming out from this. There's no use in getting all this data and then analyze all this data by the traditional models. Even the more sophisticated data sheet that you can think, and don't think Oracle or things like this. This will not simply work. You have to come up with something like this, an entity-centric model, in which basically the relationship between entity and attributes can change constantly. And so you can put all the parameters related to all the parameters, and then structure and unstructure the data, and then connect the million of data points. By the way, this is the best vignette of the so-called deep learning that I ever seen. So if somebody tells you what deep learning is, now you know this is the deep learning thing, okay? And it goes deep, and it has how-to learning system. It will not be even enough. We've been working on this for the past year or so, because the other issue is that even with the entity, you need to put together at least these different layers. This data comes from a heterogeneous source, and these are the representation. They have heterogeneous formats, and there is a lot of issue in then translating these formats. They have heterogeneous knowledge. They generate all sorts of data. These are the 40 zettabytes, by the way. And they have heterogeneous scales. So how do you combine all this? Probably into this integrated convoluted network, and this is something we've been working on. My last two slides are the most controversial one, and I asked clearance for these slides, and they said yes. It's on you anyway, so. Think about all this. Yeah, I just tried to summarize quickly, and sorry for being in a rush, and then put this in the context of the GDPR. I read carefully these 88 pages, and I found them fantastic. They are real safeguards. They are amazing. I checked in the hotel yesterday. By the time I was in the room, I got an email saying, "We got your data. You want to remove your data?" I'm still in the room. They won't remove the data from the hotel already. I said, well, but if you apply this GDPR to what we're talking about, and these are some of the principles, okay, and I'm not a lawyer, so I might have done a lot of mistakes. The data minimization, the privacy by default, the right to opt out, and things like this, and even apply to the health and the clinical trial. I'm looking at this in terms of the clinical trial perspective of a regulator and a payer. This is what's going to happen, you see. If you have data minimization, you cannot do machine learning. And if you have strict privacy, you cannot do predictive analytics. Because if I have given you the permission to analyze certain things, and then your machine, deep learning, generates new knowledge in area that I, as the principal investigator, could not have suspected. So in good faith, I cannot tell you that I'm going to analyze certain things, because I don't even know. How can you then have the privacy and opt out? You cannot really do it. The issue is not about data ownership. You can own your data. It's about access. And not even blockchain can save you from this. Because the moment I'm going down the bloodline and I'm doing the elaboration, right? At 3 or 4 stations down, you take your data back, sure. But the post-elaboration is done. De-anonymize, de-anonymize. Anonymize. I don't know anything about you. These are other issues. The regulators are not ready for this. They have a lot of knowledge that they have to build. They have no idea. FDA is very advanced. FDA have done pre-certification program. They are putting their hands and feet on this. IMA a little bit less speed, but this is again my personal opinion, and so it's going to be quite difficult. So this is my final consideration. The disruptor is here, and it's information communication technology applied to brain and brain health. It's here, and it's here to stay. This is not something that then we will go back, business as normal, as usual, and we will add some of these digital gimmicks. You know, it's not going to be like this. This is a true revolution. The duck has become a rabbit. It is a rabbit. And the bigger the data, the bigger the biological representation. So from inferential to pure representation. Pharma companies, as I was discussing yesterday at dinner, had wasted a lot of time not understanding, but I leave to the pharma executives here, not understanding what exactly this was, but now they are jumping in. Major acquisition, major merging, important stuff. So they have understood, finally, that something is going on in the space. There is not only, I need to be in the space, right? Something is happening, seriously. The immediate area for pharmaceuticals are going to be on clinical trials, customer-patient engagement. The patient-customer difference is fading a little bit. Many doctors are kind of scared about this, but this is also happening, and operational efficiency. My last question is for you. Are we ready for all this? In words, sometimes we are, but the only thing I cannot answer is how quickly this will go. It's exponential, and exponential means it's like in a rocket platform, and is launching. And I thank you very much for your attention. Thank you. What do? I stay here?
Apparently we've got some questions. They're on Slido, so I will just rush into Slido and not see them. Perhaps they're going to come up on the screen here too.
It's digital. If you're not asked the question
digital.
in Slido, you cannot
And
voice
I was
your
actually
question.
thinking while you were talking is how many of us have been advised to give up our digital devices for the sake of our mental health? Think about that one.
No.
Just shout a question, because I'm not seeing them on Slido at the moment.
Here.
Right? There we are. Okay. So the key challenge is data interoperability in the digital era. Can we collaboratively agree on working standards for data? I mean, that interoperability is a real problem.
Yes. This is a very important and very difficult question to answer. Think about this little plug to charge your phones. These huge conglomerates were unable to reach an agreement on how to interoperate the plug. Everybody has his own plug, you know, and then they go by their own way. Unless interoperability is mandatory, that's something I learned staying with IMA for so many years, we need a legal hook. Otherwise, I don't think, based on good willingness, that they will come. But it's essential, absolutely. It will make things a nightmare without interoperability.
And how can we standardize the data?
That's another very important question. What we ask is that every time you want to use any of this device, any of this measurement tool, you need to perform standardized normative data first. We would like to know the background against which this measurement is taken. And unfortunately, the field thinks that, and you have seen why, given the numbers, that if I have enough numbers, then I don't need to standardize, which is not the right attitude. We need to at least get some clean numbers laid, and then we can move ahead.
Okay, Luca, thank you so much.
Thank you.
That was such an insightful presentation.